In golf, more times than not, someone is always complaining about that annoying slice or hook that they cannot get out of their swing. Or there may be an amateur golfer wanting to know how to increase the distance of their shot. Specific biomechanical processes can help to explain why certain things happen and how to improve one's golf game. Specifically, we will discuss energy transfer in collisions, projectile motion, and the Magnus force. With collisions, during the swing, there are two types of energy occurring: gravitational potential energy and kinetic energy. Gravitational potential energy is the energy stored in a body due to its vertical position. Kinetic energy is the energy of motion. At the peak of the backswing, the club head has all potential energy and zero kinetic energy. As the golfer starts the downswing, the potential energy is converted to kinetic energy, increasing the velocity of the club head. The velocity of the club head is greatest right before impact with the ball, where almost all the potential energy is converted to kinetic energy. When the club head hits the ball, an elastic collision occurs. An elastic collision is a collision in which the kinetic energy is conserved using the equation 1/2 times the mass of the club times the velocity squared of the club plus 1/2 of the mass of the ball times the velocity squared of the ball equals 1/2 times the mass of the club times the velocity squared of the club plus 1/2 times the mass of the ball times the velocity squared of the ball, where the right side of the equation is prior to the collision and the left side of the equation is after the collision. Since some of the kinetic energy of the club is transferred to the ball at the point of contact, this transfer of energy occurs right at contact between the club and the ball. There is a decrease in the club's kinetic energy and a subsequent increase in the ball's kinetic energy, causing the total amount of kinetic energy to remain relatively conserved. This is not a perfectly elastic collision, in that some energy is lost as sound and heat energy. Once the collision occurs and the energy is transferred, the ball begins its flight towards the target. The ball will travel along a predictable path that we can calculate using kinematic equations. Using the initial velocity of the ball, the angle at which the ball is launched, the mass of the ball, the time of the flight, and the acceleration due to gravity, we can accurately predict where the ball will land and how high the ball will go. There are other factors such as air resistance that we will go into more detail later. The initial velocity can be broken into its vertical and horizontal components, VIY and VIX. Maximum height can be determined by the height equals the velocity final in the y direction squared minus the initial vertical velocity squared, divided by 2 times the gravitational acceleration. And range can be determined by the range equals the initial velocity in the x direction times time. One way to make the ball go higher is to increase the launch angle or use a higher lofted club. The loft on a driver is 9.5 degrees, while a pitching wedge is 48 degrees. While using a driver, the launch angle will be lower, causing a decreased vertical component of the velocity. Since vertical velocity is directly proportional to vertical height, a decrease in vertical velocity will cause a decreased peak height. The decreased angle of attack will also allow the ball to travel further since the horizontal component to velocity is increased. This is why a shot with a driver travels further than a shot with a pitching wedge. Another way to increase peak height and distance would be to hit the ball with a greater initial velocity while keeping the launch angle constant. Going back to collisions, if the club has a greater amount of kinetic energy during the swing, more kinetic energy will be transferred to the ball, and the vertical and horizontal components of the velocity will both be increased, allowing for a greater peak height and a greater total distance traveled. As mentioned earlier, air resistance can play a big factor in the trajectory of the ball and whether or not the ball travels in the predicted fashion. There are 3 types of forces acting on the ball through its flight: gravity, drag, and the Magnus force. The drag force acts in a direction opposite of the velocity vector. The dimples on the golf ball help to reduce drag. The dimples on the golf ball help to achieve a penetrating trajectory and maximize horizontal distance. The way it works is simple. The dimples on the golf ball create turbulence, which sucks air towards the surface. This results in a delay of separation between the air and the surface of the ball, which reduces drag. The reduction of drag allows the ball to travel further. The third type of force acting on the ball is the Magnus force, which acts in a direction perpendicular to the velocity of the ball. The spin rate of the ball is key in determining the flight of the ball. The Magnus force can cause pressure changes on either side of the ball that can alter the trajectory of the ball. For example, given a ball with backspin, the flow of the air and the spin of the ball travel in the same direction above the ball, speeding up airflow and creating a pocket of low pressure. Below the ball, the spin and the airflow oppose each other, causing a reduction in airflow and generating a pocket of high pressure. This difference in pressure causes a lift force on the golf ball, causing it to travel upwards, which helps it stay in the air for a longer period of time. This principle can be applied to topspin and side spin as well. A shot with topspin will have a resultant downward force, causing the ball to return to the ground quicker. A shot with clockwise side spin will have a resultant force to the right, and a shot with counterclockwise spin will have a horizontal force to the left. The Magnus force is a key factor that golf club manufacturers monitor. The aim is to reduce the spin rate of the golf ball in hopes of reducing slices, hooks, and ballooning shots. It is important for individuals who play golf to get professionally fit for golf clubs, because changing clubs or having a club that does not fit your swing mechanics can drastically alter the trajectory of the ball. Having a club that does not fit your swing type can influence spin rates, causing you to repeatedly hit annoying hooks or slices. That's it for this video. For all recreational golfers out there hoping to fix that one problem, hopefully this gives you insight on how to correct the problem and the biomechanical processes involved in the game of golf.